Hi everyone! In this video, I am going to show you how to use light-dependent resistor, LDR, with a PIC microcontroller. If you're new to this channel, then please subscribe to my channel and turn on the bell button. Here I'm using a PIC16F877A PIC microcontroller. This is the pin diagram of PIC16F877A. A breadboard, 20 MHz crystal oscillator, 22 picofarad capacitors, 5 mm LED, LDR sensor. First, placing the microcontroller on the breadboard. Then connecting pin 11 with breadboard positive terminal and pin 12 with breadboard negative terminal. Pin 31 with breadboard negative terminal. And pin 32 with breadboard positive terminal. Connecting crystal oscillator with pin 13 and 14. Then connecting 22 picofarad capacitors between the breadboard negative terminal and crystal oscillator. Then connecting a 10 kΩ resistor between pin 1 and the breadboard positive terminal. Then connecting the 1 terminal of LDR sensor with positive terminal of the breadboard. Then connecting a 10 kΩ resistor with breadboard negative terminal and another terminal of the LDR sensor. Then connecting LDR terminal with the analog pin A0 of the microcontroller. Then LED's negative terminal with the breadboard negative terminal. Then connecting the positive terminal of the LED and pin 1 of port B of the microcontroller through a 220 ohms resistor. Now to upload the program, place the microcontroller and the trainer board. And connecting the board with the computer. Here we need two software. First, Micros Pro for writing programs and creating hex files. Second, PIC version 2 is used to upload hex files to the microcontroller. I've attached the download link for both software in the description. Now open Micros Pro. Then create a new project. Enter the project name, device name, and frequency of the crystal oscillator that I'm using. Split LED pin at RB1 bit defines a single bit LED pin at the position of RB1 bit, which corresponds to pin 1 of port B. Define LDR threshold 512 sets a constant named LDR threshold with a value of 512. 𝐸𝐿DCON1 equals 0 𝐷 configures the analog to digital converter settings on the microcontroller. This setup makes pin 0 of port A as an analog input. TRISP 1 bit equals 0 sets the direction of pin 1 of port B as output. By setting the value to 0, the pin is configured for output. LED pin equals 0 turns off the LED connected to pin 1 of port B at the start of the program. While 1 creates an infinite loop that continuously executes the code inside it. Unsigned int LDR value equals ADC read 1 that reads the analog value from channel 1 using the ADC. The value is stored in the variable LDR value. If the LDR value is less than the threshold, it means the light level is low. so the LED pin equals 1 that turns on the LED. Otherwise, if the light level is above the threshold, LED pin equals 0 turns off the LED. Delay MS500 that adds a delay of 500 milliseconds before the loop repeats. Now click on this icon to compile the code. Here I made a mistake here. Now click on this icon and save the hex file. Now open the PIC-Kit2 software. First, erase the chip. Then import the hex file which was created in Micro Pro. Then click on Write to upload the code. The code is successfully uploaded. Now providing power in the breadboard from my power bank. It's working properly. When light falls on the LDR sensor, the LED turns off. And when the light is removed from the LDR sensor, the LED turns on.